Okay, good evening. Welcome to
SuperMath number 89.
SuperMath89. We had a long day today, so this is just going to be a review problem. One of the problems we did this morning about squares. So this is a problem out of your book. It said you have a square, and you use a side as the radius of a circle, and sort of scoop it down until you hit this line that connects the two midpoints. And then it asked an interesting question, which is, what is this angle? It goes from here and then over to there. So that angle. Okay. Challenging problem. What do you think?
Well, this is a square. It should work for any side length.
Yeah, that angle should be the same for any square.
So this is a perpendicular bisector, this line?
Yeah, it cuts across the middle.
So, since we're going to be cutting stuff in half, I'll just use 2. So we don't have to deal with fractions. So this is root 3.
Why is that?
Because this here is 2. This is a circle.
Okay.
And you have that radius. So this is a 1, 2, 3 triangle, which is 30 and then 60. 30, 60, 90 triangle.
Okay. So we're learning some of the angles. It comes down at a 60-degree angle. That's important, I guess. And then it's a 30-degree angle over here. So 30 degrees contributes something to that whole angle that we're looking for.
Well, if we could find what this bit is,
Yeah.
that would help.
That'd be very helpful. Why?
Because we have this quadrilateral, and that angle plus that angle plus that angle plus that angle has to be 360.
Okay, good.
Well, this isn't quite a straight side.
No.
So we could draw a straight side. It's the same. These sides are the same.
Okay, why is that?
Because they're coming out from this line on the perpendicular bisector. This point on the perpendicular bisector.
Okay.
And you also have,
You have a right triangle there.
yeah.
Okay. So you have some congruent triangles.
So, it's isosceles. This triangle here is isosceles. So this angle and that angle are the same.
Well, be careful. Make sure you draw your angle over to that side. That's the part of
Yeah.
the circle. Okay, that angle and that angle are the same. Okay.
So, But how could we get to that angle? So that angle is also, oh actually, this angle is this angle. Because the angles, this angle plus this angle has to add up to 90.
Okay. Make sure you draw the angle over to the line, not to the circle. Okay.
So, should probably just wiggle them a bit so we can tell.
All right.
And I know this is 30. But, how can we get to this? So, we have an isosceles triangle here. So, this angle is that angle. So, these are 75 each.
Okay.
Because angles in the triangle add up to 180.
All right.
The same angle there and a 30.
Okay.
So that means this here is, this is 15. And this, which means that this is 75.
Alright.
So 90, 90. It's 180 plus 75. 360 minus that. This part. Well, 180 minus 75 is 105. So that's what we're looking for. And then you just add the 30-bit in.
Okay.
So it's 135.
There you go. 135. Good job. Good job. That is a tough problem. No doubt about it. So you first had to recognize this was a 30, 60, 90 triangle, then recognize this isosceles triangle up there, and then chase the angles all the way down and around. Nice job. Nice job.